According to that, matrices is nothing but number of rows by number of columns. Okay.
Yes,
So
sir.
earlier in a previous class we discussed about, suppose let us imagine 2 rows and 3 columns, then what kind of matrix it is?
3 by 3. No, it is 2 by 3.
2 by 3. Excellent. So based on this is called order. Okay, am I right? This is called order. So every order is indicates number of rows by number of columns. So based on that order, we can classify the type of matrices also. Am I right? In a last class, what kind of matrices we discussed? Type of matrices. What kind of this matrix? This matrix name is what? See, yes, I am going to brush up that in a previous class. See, in a matrix, the number of column is 1. Then this kind of matrix is called column matrix. What is that?
Yes, column matrix.
Column matrix. Do you remember this one?
Yes, sir.
Right. In a matrix, now tell me the order.
1 by 3.
1 by 3. Excellent. 1 by 3. According to this statement, a matrices which has only one row, that matrix is called what?
Row matrix.
Row matrix. Row matrix. Correct. So we are determined based on this order only. Correct. Depends on order, we are deriving the type of matrix. Correct.
Yes, sir.
Right. Now tell me the third one. A matrix which has what is the order? This one?
2 by 2.
2 by 2. What kind of matrix it is?
Square matrix.
Square matrix. So according to your statement, how we can able to define square matrix instance? What is your observation?
The number of columns should be equal.
Excellent, excellent. This is the statement. This is a definition of square matrix. In a matrix, number of rows and number of columns are equal. This kind of matrix is called square matrix. Okay, we have to remember. Then that square matrix may be in the form of 2 by 2 or 3 by 3 also. Correct?
Yes.
Yes. Tell me the order, this one?
3 by 3.
3 by 3. So this is a one more example of square matrix. Correct? Even though square matrix can able to define 2 by 2 or 3 by 3 also. Correct? Now come to the point. Today we are going to discuss about determinant of A. What is that?
Det.
Det. Shortly we can say det A. Now that det A is variating the process for 2 by 2 as well as 3 by 3. Now we are going to check how it will be changed. Now see here, I am taking as a one example for 2 by 2 matrix. Is it 2 by 2 matrix or 3 by 3 matrix?
2 by 2.
2 by 2 matrix. Now have a look once. This matrix is A, B, C, D. Correct?
Yes.
In the place of A, 1. In the place of B, 2.
2.
In the place of C, 3.
3.
In the place of D, 4. Okay.
Yes.
Let us imagine this is matrices A. Okay. Now, what is the order?
2 by
2
2.
by 2 matrix. Now, whenever you want to find out the determinant of 2 by 2 matrix, the procedure is, observe here, A into D. What's that? A into D minus B into C. What's that? B into C.
B into C.
Yeah. So, shortly we can say AD minus BC. How we can able to say? AD minus BC. This is called determinant of 2 by 2 matrix. Understand? Yes. For example, I am taking as a 1, 2, 3, 4. Okay. This is 2 by 2 matrix. Okay.
Yes.
Tell me now, what is the data value here?
It will be 4 minus 6 minus 2.
How we can do? A, B, C, D.
4 minus 3 into 2.
AD means 1 into 4 minus BC 3 into 2, correct? Or 2
Yes.
into 3. Yes. Now 4 minus 6, correct?
Yes.
4 minus 6. What's the result? 4 minus 6?
Minus 2.
How much? Minus 2. Yes. Here the value of determinant A, how much we got?
Minus
2. Now very important points we are going to discuss about determinant A. Two criteria are there. If det A is equal to 0, then this is called singular matrix. What is that?
Singular matrix.
Singular matrix. If determinant A not equal to 0, that is called non-singular matrix. What is that?
Non-singular.
Non-singular matrix. So now tell me, whatever you got the minus 2, is it singular matrix or non-singular matrix?
Non-singular.
Non-singular matrix, because minus 2 is not equal to 0. Therefore, given matrix A, what kind of matrix? Singular matrix or non-singular matrix?
Non-singular.
non-singular matrix. So given A is non-singular matrix. So whenever given matrix A, we can able to determine the nature of the matrix two types. First one is what? Singular matrix. Second one is what? Non-singular matrix. Yes. Now tell me, now do the determinant of this.
Zero.
What's the
It is a
value?
singular matrix.
Yes, this is an example of singular matrix. This is an example of singular matrix. Right. Now, shall I erase this one?
Yes.
Right. Now, observe here. What is the importance of determinant A? Now we are going to discuss. Based on this determinant A, for 2 by 2 matrix, we are talking now. A inverse is nothing but we have the formula adjoint A by determinant A. Do you aware of this one?
Yes, sir.
Yes, A inverse is equal adjoint A by determinant A. Suppose if I am taking about 1, 2, 3, 4, we need to find out A inverse value. Okay,
Yes.
what is the order of this matrix?
2 by 2, 2 by 2.
2 by 2. Now, see, what is the determinant A value here?
It will be -2.
Minus 2, very good. Minus 2 is equal 0 or not equal 0?
Not equal.
Not equal 0. Then what kind of matrix it is?
Non-singular.
Non-singular matrix. Now you can observe now if determinant A is 0, what happened?
Non-existent.
Yes, cannot define. Correct?
Yes.
If determinant A is 0, earlier we said 1, 2, 3, 6. What kind of matrix it is?
Singular matrix.
Singular matrix. Suppose if I ask about find out A inverse means, now tell me what is the value of A inverse for this?
Not defined.
Not defined. So without doing of adjoint A, even though without doing of adjoint A, we can able to say that given matrix is exist or not. Am I right?
Yes, sir.
Yeah. If it is a non-singular matrix, it will be exist. If it is a singular matrix, it won't exist. Correct?
Yes, sir.
So that's what depends on this determinant A. Two kind of conditions we are going to discuss. If determinant A is equal to 0, this is singular matrix. So every singular matrix, it has no solution. What's that? It has no solution. Okay? If determinant A is not equal to 0, what kind of matrix it is?
Non-singular.
Non-singular matrix. So every non-singular matrix, it has solution.
Yes.
What kind of solution? It has unique solution. Okay?
Yes.
It has unique solution. So for example, I gave here 1, 2, 3, 4. So here it seems to be structure A, B, C, D. Am I right?
Yes, sir.
For 2 by 2 matrix. Now observe, if I want to find out A inverse means for exclusive 2 by 2 only, whatever we are discussing, the process will be applicable. So that procedure is B, A minus B minus C. How it will be adjoint A? How it will be? D.
AD plus
A.
BC.
No. D, A minus B minus C.
Yes.
So that means A and D are, this element should be reciprocal, correct? Mutually
Yes.
exchange.
Yes.
AD becomes what? DA.
DA.
AD becomes now DA.
DA.
And B and C becomes now minus B and minus C. So same way in determinant A already you define that A inverse is equal to adjoint A by det A. In previous we discussed determinant A is nothing but what? AD minus BC, correct?
BC. Yes.
Right. Now make it substitute here. DA means what? 4, 1, correct?
Yes, sir.
4, 1. Then minus B minus C means what are the values?
Plus 6.
No. Minus 2, minus 3.
Wait. You're telling me to make the math. Okay, fine.
Got it?
Yes, sir.
Now tell me the AD minus BC.
For this, it will be, this will be -2, no, sir.
Minus 2. Now, so earlier you gave the conditions. If it is a non-singular matrix, it has solution. Now we can able to know that, yes, we have the solution for this, correct? So what kind of solution we will get? I will look once. 4 by -2. What's that? 4 by -2. Then -2 by -2. -3 by -2. 2 by -2. Correct? Sorry, 1 by -2. So now we have 2 1s, 2 2s get cancelled. Correct?
Yes, sir.
So what is the solution we get? Yes, -2.
1 -3
-3 by 2.
-1 by 2.
-1 by 2. This is the value of what? A inverse.
A inverse.
So in examination, in MSET, they are asking that find the A inverse means in examination, no need to write each and every step. Okay. For our awareness, we are taking each and every criteria. So in examination, they are asking about if A is equal to 1, 2, 3, 4, then find out A inverse means directly we have to write. How we can write? Tell me now.
It will be A inverse. Okay. The last value, sir.
1, 4 becomes 4,
Okay,
1.
okay, wait. 4, 1 minus 3, so minus 2 minus 3.
Very good. By, what's the derivative value?
By minus 2.
Minus 2. Right. So basically you have the idea. We can able to write like this.
Yes.
Right. So then you can do the simplification easily. Am I right?
Yes, sir.
This is the hint for you. Exclusive. This procedure will be applicable for what? What kind of order?
2 by 2.
2 by 2. So what we are doing here for A inverse, A, B, C, D becomes now DA minus B minus C by AD minus BC.
Yes.
Okay. Right. Shall I erase this one?
Yes.
Right. Now we are going to discuss about A inverse for 3 by 3 order. Okay.
Yes.
Right. So now check once. We are taking 1, 5, 6, 2, 3, 8, 3, 5, 7. This is the A. In examination, they are asking about find A inverse.
Yes.
So what we have to check first according to formula?
But,
A inverse is nothing but adjoint A by determinant A. By seeing of this formula, based on that determinant, we can able to classify either it's a singular matrix or non-singular matrix. Correct? If it is a singular matrix, what happened?
if it's a singular matrix means
It has no solution.
Get solutions. We can't get solutions.
Yes, that's what it has no solution. Right? If it is a non-singular matrix, what happened? Now we are going to check whether it's a singular matrix or non-singular matrix. See the
You have to
procedure.
find the determinant.
Yes, that A we need to find out. The that A process is symbols plus minus plus. For first row.
Now it will be minus plus minus, then again plus minus plus.
Very good, very good, very good. So now for determinant A, we need to take only first row itself. Remember, so in a first row, what's the first element?
1.
1. What symbol it has? Plus. So plus you have to write, and element also you have to write. Once I choose this 1, see opposite row, opposite column should be eliminated. Then we have to take submatrix. What is that? 3, 8, 5, 7. Correct? It seems to be A, B, C, D structure. So AD minus BT, shall we find out AD minus BC from this?
Yes.
Yeah, make it.
This will be 21 minus 40 minus 19.
40. Yes. How much we'll get?
Minus 19.
So we can continue now. Later we will do the simplification. Right? After
Yes.
this, middle of the term represent what? Negative.
5. Negative. Yes.
Negative. Negative. So first you have to keep the symbol, then follow the element 5. Now, once I choose this middle of the element means opposite column, opposite row should be eliminated. Then
Okay.
2, 8, 3, 7 is a submatrix. Am I right?
Oh.
2,
14 minus 24.
Yes, 14 minus 24. Excellent. Then what about third one? 6
Plus 6.
plus 6. See, if I choose this one, opposite column,
minus
opposite
9.
column. Excellent. 10 minus 9. Now do the simplification. 21 minus 40, whatever
Minus
you said
19.
earlier. Minus 19.
Plus 50. I don't know. Minus. Okay, this will be minus 10, and that will be plus 6.
Minus 19. Minus into minus.
Plus
Plus 6.
plus 6.
So what's the result here?
37.
36 minus 19. 37. Now tell me, 37 is equal to 0, not equal to 0?
Not equal to 0.
Not equal 0.
So it has
So what
solution.
kind of matrix? Yes, we determine it has a solution. We can able to get the solution. This
Yes.
is our conclusion. Correct?
Yes. Yes.
So in MSET, what happened? Some questions, no need to do entire procedure. Just have a look once by the solving of determinant A. Okay. Sometimes he may give the singular matrix. Okay. Then
Yes.
he is asking that check whether it is a singular matrix or non-singular matrix. Got it? Whether it's a singular matrix or non-singular matrix. So in option,
determinant.
yes, they are asking that what kind of matrix. A means singular matrix. Options are singular matrix. Option B non-singular matrix. Option C square matrix.
Yes.
Option D none. What's your option?
It can be singular, No, it can be non-singular and square also.
Non-singular as well as square. But you have to remember one thing. Every square matrix is consists of either singular or non-singular. Correct?
Okay, so it will be non-
For non-square matrix, we won't get any determinant value. That you have to keep in mind. Once we want to find out that A means it should be a square matrix. Then only the determinant A is possible. So I will give you one example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now tell me what's the order? See again.
Oh wait, no, my God. Okay, this will be
How many rows it has?
4 by 3. 4 by 3.
How many rows it has?
3 rows. 4 by 3.
How many columns it has?
3 by 4.
Yes. See that. Observe carefully.
Yes,
Correct?
yes.
It is a what kind of matrix? 3
This
by
is
4 matrix.
non-square
3 by
matrix,
4.
so it won't have a
Yes,
determinant value.
yes, absolutely correct. Based on that order, we can able to determine whether it's a singular, whether it's a square matrix or not. Am I right?
Yes.
It is a non-square matrix, correct? It's a not square matrix. So just now I said for square matrix alone, we can able to find out the determinant A value, correct?
Yes.
So for that, what you have to do? Remember, extreme last column should be eliminated. Column should be eliminated. Once I eliminated this column, what happened? Tell me, except
3 by 3.
what happened? 1, 2, 3,
5,
5,
6, 7,
6, 7, 9, 10, 11. Now what's the order for this?
3 by 3.
3 by 3. Now shall we able to do this determinant A for this? Now it is possible. For 3 by 4, is it possible?
No, sir.
So what's the basic rule? When we want to find out determinant A means it should be a square matrix. What is that? It should be a square matrix. So once it is a square matrix, then decide whether it is a singular matrix or non-singular matrix. According to your statement, provided options are A singular,
B non-singular, C square.
C square, D, B and C.
Yes.
Now what is the correct answer? At that moment your option is D correct. If I am giving like this square matrix, singular matrix, non-singular matrix, square matrix, option D none. Now which one is correct?
Non-singular. No?
Yes, your option will be non-singular matrix, because every square matrix only can able to find out the determinant A. This is default factor, correct? So in option, there is no multiple options are not provided.
Yes,
only
sir.
single options are provided. At that moment, what we have to do? We have to choose only
The most
single
accurate.
option. Yes, most accurate. Absolutely correct. Most accurate answer we have to check. Square matrix also correct. What is the condition? Every square matrix should be follow the determinant A. So this is default point. That's what most suitable answer is B.
B.
Well, come to this one. Singular, non-singular, square, on option D provided B and C. So means there is one facility provided, multiple option criteria. So welcome to this scenario, our option will be changed, our mindset will be changed, because there is a provided one B and C multiple option. At that moment, my option is this one. So this is the way we have to choose the answers according to your situation, according to given options in examination. Now we are taking same example, whatever you said earlier. Just I am go through with previous example.
Yes.
Then you can able to realize how to find out A inverse accurately. Now see that earlier you took this 156, 238, 357. Am I right? Determinant A value we decided that is 37, which is not equal to 0. Correct? Now we are go through with adjoint A for this. Adjoint A. For 3 by 3 matrix, if you want to find out adjoint A means, already we know that plus minus plus, minus plus minus, plus minus plus criteria. Correct? Now,
So, again you have to solve it. 1 into
for first row, already we solved. Correct? So how we can solve this one? 1 into 21 minus 40. Correct? 5 into 14 minus 24.
14 minus 24 and
6 into
6 into
10 minus 9. So
Yes.
there is a small variation in between determinant and adjoint A. See, when go to the adjoint A, see, we have to write like this: cofactor of 1. Cofactor of 1. So at that moment, you should not consider this 1. Should not consider 1.
Yes,
But you have to
yes.
consider symbol. What's that? Symbol.
Yes.
And whatever you did AD minus BC, that you have to consider. So now write the similarly cofactor of 5. What is the symbol will be follow?
Minus 10.
Minus 10 should, yes, minus 10. So minus of minus plus 10. Now next one is cofactor of 6.
Plus
Yes.
into minus is equal to minus 1.
10 minus 9.
Oh, when
So-
it is 6, no, okay.
Yeah. So 6 should not consider.
No, we have not considered.
Yes. So up to that, this is one row completed. Am I right?
Yes,
Now, say for second row, cofactor of 2. What
Yes.
kind of symbol you have?
minus.
So do the AD minus BC structure. What happened? 5, 6, 5, 7.
Yes,
How much will get? 35 minus 30.
30.
Minus 5.
Right.
Correct?
Yes.
Now, cofactor of 3. What symbol will you have?
It will
Plus.
be 7 minus,
Minus?
18.
18. Excellent. 7 minus 18. What will the result?
Minus
Minus
11.
11. Next one is what?
8.
8. Symbol is what? Negative.
It will be 5 minus 15 minus 10.
This is what? Second row. About third row?
3 is it will be 40 minus 18.
Cofactor of 3. Yes, tell me now. What's the symbol? Plus. So,
Plus.
what's the value here? 40 minus 18. How much?
22.
22. So, now symbol is
5 will be 8 minus 12, which will be minus 4. Plus 4.
minus 4. So, plus 4. Last one.
It will be
7.
3 minus 10. Yeah, 7.
Yes, 3 minus 10. How much?
Minus 7.
Now you got these values. Very careful. We are going to form a new matrices. In the place of first row, we got new values, correct? So write down minus 90, 10, 1. What about second row? Minus 5, minus 11, 10.
Yes.
What about third row? 4, minus 7.
Yes, sir. 22
Yes.
plus 4 minus 7.
Yes. Now, adjoint A means very, very important point. Adjoint A means B transpose you have to, what we have to do? B transpose. So how you have to do? Yes.
Which one?
1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. Okay. This is 3 by 2.
3
This
by
is
2
two.
and that will be 2 by 3.
Yes. What kind of matrix will get? 3 by 3.
by 3.
So which should be consist of 3 rows and 3 columns.
Yes, sir. So first row and second first column. So 1 into 1 plus 4 into 4, it will be 17.
17. Very good. Now
Then it
first
will be
row, second column.
So 2 plus 21. The third will be 3 plus 4, 6 are 24. So it will be 27.
Next, second row, first column.
Yes. 2 plus 22.
Second row, second column.
4 plus 25, 29. Then it will be 6 plus 30, 36.
36. Next, third row, first column.
3 plus 20, 27. Then it will be 6 plus 30, 36. Then it will be 9 plus 36, 45.
So, what kind of matrix we got?
3 by 3.
3 by 3. So, without solving of this, even though we can able to understand
You can
what
see
is the
what.
what kind of matrix we'll get, correct?
Yes, sir.
So, this is a very advantage for us. In examination, there is a 2 criteria they will ask. Check whether BA is exist or AB is exist. If it is exist, what is the order of the matrix? Like that they will ask. Okay. By observe of this basic fundamental rule, we can able to understand product of 2 matrices is existence or not. Correct?
Yes, sir.
Then second thing, what we can understand, what kind of matrix we're going to get. Correct?
Yes, sir.
So this is a very, very important. So you have to keep in mind. Okay.